we have another stalwart. Ladies and gentlemen, CTO Global Data Center Solution Sales, Huawei. Can I have Mr. Ronald Wright Rasperger on stage, please? Good evening, sir. Good afternoon, sir. Good morning. I'm sure we're all looking forward to one hell of a session from you as well, sir.
It's always a little awkward when I'm the thing right before the break. So especially when we're running a little late. So I want to just take a little bit of a step sideways this morning in looking at AI, because I think that there's a lot of discussion about AI, but maybe not as much understanding. So if we look at the kinds of things that are going on within the technologies that need to be used within the banking and financial services industry, we see lots of new kinds of use cases. We've heard about chatbots, we've heard about the blockchain, we've heard about lots of cases. And if you look at that red circle on the upper right there, those are the areas that are impacted by artificial intelligence. But there's a lot of confusion, I think, about what is artificial intelligence. And in fact, if we go back in history, the guy that invented cut and paste is a guy named Larry Tesler. And sometime around 1970, he said something that has been shortened to become Tesler's theorem, which is AI is whatever hasn't been done yet, right? And more recently, when we've gotten discussions about AI, we've talked about, well, if it's implemented in Python, it's machine learning. If it's implemented in PowerPoint, it's AI. So there's a lot of marketing. I'm expecting, we went through this with cloud computing a few years ago. And I'm expecting that one of these days I'm going to walk into a supermarket and on the shelf is going to be a box of cereal that says it's AI enabled, right? So AI has become much of a generic term, and it obviously has a lot of use. But I think what we need to do is maybe look a little bit deeper into what is AI to understand because you can't just as a CIO say, okay, I want to do AI. You can spend a lot of money, you can throw a lot of money at consultants, at your own internal organizations, but if you don't really understand what your goal is and maybe some of the underlying things, there will be too much confusion. So the way that I look at AI is there are really three types of AI. One is machine learning, and that's where you're using data mining, you're using business knowledge to improve outcomes. So we just heard from SBI about the ability to automate the process of deciding to give loans and how big they are. And this is a very common use case for the machine learning kind of AI. The second kind is deep learning, where you're trying to automate the learning. And you're automating the machine learning using some kinds of technology uses. And the last case is around the artificial learning where, now we're talking about HAL, right? And whether or not HAL is going to let us back in. So we're going to kind of ignore that one right now. The two that for financial industries are important are machine learning and deep learning. Well, let's look first at machine learning. Machine learning is really all about statistics. And there's lots of different kinds of statistical capabilities that can be used. A lot of us, when we were in college, we studied many of these, and we only have kind of this vague memory of, what is a Bayes theorem and that sort of thing. But it's all about being able to take huge amounts of information and be able to analyze it, look through it to find the result we're looking for. Deep learning, on the other hand, uses something entirely different, which is neural networks. We hear a lot about neural networks. There are lots and lots of different kinds of neural networks. We can really think of it as unsupervised learning. So where we have machine learning, we're doing a lot of the work with the data ourselves. We're looking at the outcomes. Whereas machine learning, we're giving the information to a bunch of technology and looking and waiting for it to tell us the answer, right? Things like facial recognition, image recognition in the oil and gas industry, things like reservoir analysis, that sort of stuff. And the hard part with this is picking the right kind of a neural network structure. This is the one that's used for facial recognition. There will not be a test on this later. So if we look at machine learning, how can that really be used? Well, this shows a lot of different industry use cases. The ones that I've highlighted in red are the ones where in the financial services industry, things like risk analytics, things like in the insurance side, premium rate optimization, understanding what the real impact of changing rates or of taking different factors into account relating to your risk profile, fraud detection, and one of the things that's always common across everything is, of course, is customer retention. Because you want to be able to make sure that once you have a customer, that you're not going to lose them. And almost all of these cases are really used for machine learning, right? They're a case where you have the information, you run it through various algorithms, and that you make your decisions based on that. So these are not magic deep learning kinds of things. These are just really sophisticated uses of statistical methodologies. And so there are different areas that these technologies can be used within the financial industry. So some things, like facial recognition, have a lot of uses within the financial industry. Everything from when an important customer walks into a branch that their wealth management partner will get a notification on their tablet that they've come in and they can rush to the front door and greet them, to uses we've seen with, of course, with every ATM, there's a camera, right? And so one of the banks in China decided, well, rather than have that camera just be for later we can find out who robbed the person that was at the ATM, let's try to use it for identification. And so I can go up to an ATM and press the button that says, recognize my face, and I can do transactions without any card. Right? So these kinds of things are deep learning kinds of applications. The most sophisticated chatbots. Earlier chatbots, because chatbots have been around for, almost 20 years, I think, but the early uses of those were all statistical. And now the machine learning, now they're using much more around deep learning. Machine language, spoken language recognition is now pretty much as good as it is for real people. At least in the research side of things. And so there are a lot of new kinds of uses, but the machine learning side is really where you can make some immediate impacts. So I just wanted to talk a little bit about how do you get to use this AI, right? So there's two steps in all of AI. The first one is called learning. And learning is where you take a whole bunch of information that you already know the answer, right? You know that the person defaulted on that loan. You know that the person left you as a customer. And you have all of this different information, and the challenge is to find the relationships between that so that you can figure out what are the trends, what were the underlying things. We have a banking customer who has looked at the customer retention side of this. They started with over 300 attributes that they were trying to figure out what's the relationship between those to be able to predict that a customer was about to leave them. And it was everything from how often they had called into the call center, how often they had come into a branch, how often they had used ATMs, how often they had used the applications on their phones, PC banking, etc. Everything had to all be brought together to be able to do that. And starting with these hundreds of different potential variables, they ended up being able to reduce it down to about 50 that they really cared about that were going to predict that. So you manually label these outcomes, you apply the algorithm, and essentially you have used guesses for machine learning. For deep learning, you use the neural networks that I mentioned earlier, and the key is data, right? You have to have lots and lots of data to be able to utilize this, and this is one of the keys to being successful. The second thing is then running it, right, which is called inference. And that just means that the algorithms or the neural networks are inferring what the outcome will be based on the rules that you've come up with. So this is the run side of the equation. So the thing that I think people really underestimate is the amount of data that it really takes to be able to be successful at doing this, and where to get it, right? So certainly you have lots of information in your own internal data warehouses, but a lot of it is still very badly disconnected. One of the things that the bank I was mentioning before found was that when people were going into the branch, were trying to put together a 360 view of their customer, but the problem was that the customer service people in the branch weren't really cooperating. So they put in the branches that you would go into, that you would swipe your card, and based on what kind of a card it was, you would get your number of which person you were supposed to talk to, what your order was, that sort of thing, right? But what happened in practice was that in order to speed up people coming into the branch, the customer service people would pre-print a lot of these slips and then just hand them out when people came in the door, right? So they lost all of that information. They also found that the information from their call centers was never combined with any other information, right? They had to keep all of that data because it was required by the regulator, but it was never tied with the branch visits. It was never tied with the other things that were coming out of the various efforts of where they were touching their customers. And they also then needed more information from the external sources. The gentleman from SBI was just mentioning about trying to get social information, about trying to get news information and bringing that into the equation. These kinds of unstructured data are brand new sources of potential knowledge that can be used for making more profitable decisions. So what do I need to do that? Right? So this is where we finally get into the area of I need some kind of a big data platform. And Hadoop is an open source platform that is the common underlying technology that is used for most big data kinds of applications. You need some kind of inference and some workbench to be able to do the analysis and then runtime to be able to do this, because these typical Hadoop platforms are very good for being able to analyze data, but they are not very fast, right? When we look at deep learning, now we have a much tougher area, because the training sides of this utilize these neural networks, and now I need much more comprehensive kinds of technology support, either graphical processors or specialized chips that do neural networks, and those are increasingly being able to be found on public networks or on public clouds. We're also seeing them within private clouds now as well. And then for inference, depending on what the outcome of the algorithm is, maybe you can run it on servers. But I guess one of the things to point out is that most of your use cases are still looking at big data platforms, right? And even for this, if you don't have the underlying data, you either need to get a packaged solution, like a packaged chatbot or a packaged facial recognition, or you need huge amounts of data that you've provided for yourself. And then to run it, you need the similar kinds of technology, but not the same. So one example is that if I've already got the neural networks that I know I want to run, then there's specialized chips that Amazon has put in Amazon Web Services, really good for inference, but not for the training steps. So again, you have to understand what the problem is that you're trying to solve and how to go about doing that. So why do people care about this? Well, there have been some fairly dramatic kinds of results. One of the branches or the banks in Russia, Sberbank, in the insurance side of things, they went from 500 underwriters to 50 through and got a substantially better risk outcome as a result of applying AI, the machine learning kinds of AI. China Merchants Bank was getting the heck beaten out of them by online credit people, and because their credit authorization process for a small business took 3 weeks. And whereas their competitors were giving almost instant access. So by putting in place the right kind of a large data lake, if you will, platform, they were able to then take things that were coming out of the technology areas and also feeds from other services and be able to put that together to be able to provide online access. ICBC, another huge customer bank in China, increased their marketing efficiency, doubled it. WeBank is a 100% online bank. They have done what the SBI was just talking about of I just click a button that says I want a loan, and I don't tell it a thing about my credit history, about my salary, about anything. It uses the knowledge it's gained about all of my social interactions to determine how much that it's willing to give me, and their risk profile is much better than traditional banking risk. Alipay is using facial recognition for payment in stores and other kinds of cafeterias. Now, on the campus at Huawei now, when I go into the coffee shop, it will recognize my face and automatically deduct from my account the money for the coffee that I buy. And this is just for one of our customers where we did with them the real-time fraud detection. It used to be, I happened to be a customer of this bank, and it used to be I would be overseas, I would use my ATM card somewhere, and I would be down the street or even the next day when I got a call from them saying, was that you, right? It's not particularly effective if it wasn't. But now I'm still standing at the ATM when I get the call. So they've made huge improvements in this, but again, they did it by building this entire foundation of all of the data that they were able to do. So at Huawei, we're trying to provide support for all phases of the AI use that people need. Everything from the machine learning to the deep learning capabilities. We have the big data capabilities, we have data warehouse database capabilities, and then we've just recently announced new chips that actually are neural network chips that make things much more efficient as well. We're deploying them in our public clouds. We're also using them in private clouds. So in summary, I think AI is hot. It's getting all of this press, but it's a little more difficult to understand, and we really need to, I think, drop down into the basics, that a lot of the applications don't need to get all bound up in this whole neural network and deep learning kinds of environments, but you do have to create the foundation. You have got to bring all of the data together in a way that you can begin to use it, and then have the technologies and the people to be able to put all that together, because in the future it's going to be required for you to be competitive. Thank you very much.